So today we will study weathering and erosion. Basically, what we mean by weathering, that is all the processes which occurs uh, over the earth and results for fragmentation, disintegration of rock mass into several smaller fragments. That is known as weathering. So in weathering, uh, basically rocks are separated out or fragmented from its parent body, and very minute or almost negligible amount of transportation is associated with weathering. In case of erosion, that is the main transportation part. The weathered material are being carried away by the natural agents and deposited in a place. So that is main uh, what we mean by weathering and erosion. Now, as a geomorphologist, we are concerned with the rates at which different weathering processes operate as a function of environmental conditions and with the nature of weathered material that is produced. So we are considered about the rate of weathering, that is basically the function of the local environmental conditions as well as global environmental condition also. Also, the nature of the weathered material which is produced by those uh, weathering processes. At the same time, we are also interested in how the weathering processes gives rise to different kinds of landforms. Okay, so that is the main fundamental aim of a uh, geomorphologist. So weathering is mainly occurred over the earth's surface. Mainly it is a superficial process, although very few subsurface processes are also occurring there, but mainly it is the surface process where most of the physical, chemical and biological processes are observed or occur over the uh, rock bodies. Now, weathering can be defined as an adjustment of the chemical, mineralogical, and physical properties of rocks in response to these changing environmental conditions which occurs over the earth's surface. So rocks basically try to cope up with the changing environmental condition, changing pressure, temperature, changing chemical condition, and during this uh, coping out with the changing environmental conditions, rocks try to adjust themselves by some way. And during this adjustment, uh, basically the rocks are fragmented or broken apart from the host large body, and that is known as weathering. So a rock shattered through physical weathering, that is the processes uh, cause the breakdown of the original rock into smaller particles by the physical processes. Uh, the other way rocks can be broken out or rocks can be fragmented, that is the chemical weathering, in which the chemical processes lead to the release of compounds uh, in any natural solution and thereby produce new mineral products. So here is a fundamental difference between physical weathering and chemical weathering. In physical weathering, only the pre-existing rock mass is broken. There is no chemical change occur. Whereas in chemical weathering, uh, the minerals within the rock bodies, they are changing their composition as well as mineral structure. Okay, now uh, for a rock which broken or which fragmented through physical weathering will be more liable to chemical weathering, because whenever the rock becomes fragmented due to physical weathering and form numerous smaller fragments, numerous smaller pieces, as you can see in this picture, the rock basically particles. Simultaneously, the more and more surface area of this rock body is now exposed. Here you can see more area, fresh rock is exposed, more and more surface area is now exposed in forms of these broken fragments. So basically physical weathering um, is liable to more and more chemical weathering, because for chemical weathering it occurs mainly on over the surface condition. So as more and more surface area is available now due to physical weathering, so chemical weathering will be more intense. Conversely, chemical weathering um, means the chemical solutions, they can percolate through the microfractures in the rock, in which on those microfractures maybe physical weathering will not so prone, but the chemical solutions, they can percolate through the microfractures in rock, and by chemical reaction they will subsequently weaken the rock mass, thereby that will also helps in uh, promoting physical weathering in a more intense way. So both physical weathering and chemical weathering, they basically encourage the other type to function more effectively, more intensely. Okay, as I already told, now after weathering, the broken fragments are moved along the down slopes due to the action of gravity and the natural agents that like wind, water, and glacier. They basically carried these masses through the down slopes, which is known as erosion, and ultimately deposited in a depressed area below the base level of erosion, that is which is known as basin. Now, as I already known that there are three major rock types found in nature, we are already familiar with these, and the three rock types are igneous, sedimentary, and metamorphic. Igneous rocks are formed from the molten material or magma by subsequent cooling and crystallization at or near the earth's surface. Sedimentary rocks are formed due to fragmentation of pre-existing rock. That pre-existing rock may be any kind, that may be igneous, that may be metamorphic, or that may be sedimentary rock, or otherwise uh, simply they are, sometimes sedimentary rocks simply are fragmented from a pre-existing rocks and the broken pieces deposited in a basin, and subsequently during diagenesis they become solidified and cemented and form clastic sedimentary rocks. Similarly, a sedimentary rock may be deposited from the chemical solution, and and in those cases we call them as non-clastic sedimentary. Metamorphic rock, these are the rocks which form due to solid state change over in presence of increasing pressure, temperature, or any fluid uh, from any pre-existing rock. So these are the three rock types, and we all know that these are mutually interlinked with each other and runs through a continuous cycle which is known as rock cycle. Now, as I already told you, weathering involves three processes, and that is mechanical weathering, in which physical processes are responsible for breaking down of rock mass. Second is the chemical weathering, in which chemical reaction is involved for wearing away of rock mass, and in this process the chemical composition is changed and produce new chemical compounds. Third one is the biological weathering. In this type, some biological entities are responsible for weathering, and they use both physical and chemical type. So it is basically a combination of physical and chemical weathering done by some biological entities. Now, the mechanical weathering can be found in nature in mainly four types. First is the frost action, second is exfoliation, third one is wetting and drying, and the fourth one is hydraulic action. The first is the frost action. Now, frost is an irresistible rock breaker. This type of weathering is mainly occurred in cold regions, where during night time the liquid water freezes and formed ice. Now, in these regions, when water fills the voids, or rather cracks or pores of the rocks, then during night when it freezes, the water molecule expands by more than 9% of its volume. As we know that at 0 degree centigrade, 11 cc of water produces 12 cc of ice. So ice is much lighter than water, but it has higher volume than water. So the volume increase happened during the freezing activity uh, from some amount of water, and that increased volume results and exerts a pressure of about 150 kg per square meter to the rock walls. So these rock walls per square centimeter, they suffer about 150 kg of pressure due to this increase of water volume during freezing activity. Okay. Now, due to this huge amount of pressure, the rocks are ruptured and fragments are wedged apart to become loose. So as you can see, due to this increase in volume, the rocks are ruptured and they gradually become separated out, or the cracks, the voids become more wide, more opened up, and ultimately they become separated from the host body. So as already, this process is known as freeze and thaw. Also, the process is known as ice wedging, and as I already told you, this type of weathering also this type of weathering occurs in the cold regions, which we particularly found in the high latitude and high altitude areas, that is on mountain tops. The next type is the exfoliation process. Uh, what happened in exfoliation? Basically, exfoliation is the wearing away or uh, removal away of rock mass in parallel layers, like the onion skin. So exfoliation can be occur or can be done in two ways. The first one is the thermal expansion and contraction, and second one is due to unloading. So first one is due to the differential heat, condition, and the second one is due to pressure. So first we coming to thermal expansion and contraction. These kinds of uh, physical weathering processes is particularly found in arid regions, desert regions, but the area should not be completely dry. The area must suffer some occasional rainfall, very less amount, but occasional rainfall should be there. Now the rocks, basically they are very low thermal, they have very low thermal conductivity. That means they are not very good conductor of heat from one point to another. So during the daytime, when there is intense sunlight, the upper surface of the rock, they becomes much and much hotter than the inner surface, which occurs only few centimeters below the top surface. Similarly, the rocks composed of different kinds of minerals, due to their different colors of the minerals, there will be some black colored mineral, there will be some light colored mineral. So due to this color difference, the individual mineral grains will also uh, warm up faster or cooler depending on their color variations. So darker mineral will becomes much more hotter than the lighter minerals. Similarly, during night time, the darker mineral requires much more time to cool down, whereas the lighter mineral readily be cool down during night time. So this intense heating of the top surface of the rock layer, as well as depending on the mineralogical variations over the rock surface, in contrast to the inner layers or in contrast to the other mineral grains, this will produce a thermal stress, and due to that thermal stress, the rocks is fragmented into several surface parallel layers, and that is known as exfoliation. As you can see here also, that the top surface is being separated out as the onion skin, is the skin is being wired away. So after removing of this layer, new layer is exposed, and the same phenomenon is repeated again. This is another process by which exfoliation type of weathering is found in nature. What happened, basically this type of uh, weathering is mainly found in igneous and metamorphic rocks. That means those rocks which generally formed um, far below the surface, that means deep inside the earth. Now the minerals formed during igneous and metamorphic processes, those minerals are particularly stable in these conditions, in these underground conditions. Suppose X, Y minerals are formed, and they are stable in this pressure temperature conditions. Now if some way or some weather erosion occurs and this upper part of the uh, earth material is removed away, so now this rock is exposed to a new pressure temperature condition, that is a superficial pressure temperature condition. So in this changed pressure temperature condition, the minerals already formed, they may not be stable, and due to this sudden release of overburden pressure, the minerals will expand. That means the rock is expanding in volume, and consequently uh, fractures developed within it, and mostly these are parallel to the earth surface, and sometimes these are also perpendicular to the surface. So again, like the thermal heating and cooling, similarly here also onion skin like rock fragmentation, rock weathering is also happen due to simply pressure release, and that is known as unloading type of uh, weathering, which ultimately results in exfoliation. Here you can see this two different pictures. First one is the dome explosion. It's a large dome where the upper surface is being removed away by layer. At the right hand picture, which is a, you can see a large ball shaped rock mass, uh, and here also the uh, outer surface is removed away by layer. As this looks like a large ball, large sphere, so it is also known as spheroidal structures. The next type of weathering is known as wetting and drying. So this type of this type of physical weathering is particularly observed in um, clay-rich rocks, that is particularly the mud rocks, the shale. Now the clay minerals within the rocks, they are repeatedly wetted. Whenever they get some water, they becomes wet, and after that, when they are exposed to intense heat, they suffer drying. So the absorbed water by the clays that occurs within the pore spaces of the clay minerals, they are evaporated and form some kinds of shrinkage cracks. So this alternating swelling due to uh, getting water and shrinking due to evaporation of pore water, this repeated wetting and drying cycle uh, gives a fatigue effect to the uh, fine grained sedimentary rock mass, that is clay rich rock mass, and ultimately they will produce this repeated wetting drying cycle, they will produce these kinds of cracks, and the upper layers are removed away by some kinds of flakes. uh, and the one famous example found in unconsolidated sediments, that is the mud cracks. The same type or the same procedure is also happened in rock bodies, also in fine-grained sedimentary rocks, particularly in mud rocks, shales. They will also broken apart by these wetting and drying processes. The last one is the hydraulic action. Here, the weathering happens due to the physical impact of rains or physical impacts of ice crystals, hails. They will impact very forcefully over the earth's surface, and they sometimes uh, are responsible for removing away or for fragmentation of the loose sedimentary particles, or sometimes the unconsolidated sediments, and it also sometimes affect the very fine grained loosely cemented sedimentary rocks also. So this is the direct physical impact uh, which occurs due to pouring of rainfall or ice crystals from the upper atmosphere. The next type of weathering is the chemical weathering, where rock masses are broken or rock masses are uh, weared due to some chemical reactions occur over the surface. And in this type, as I already told you, uh, the chemical composition is changed, and it will produce or it will form new chemical compounds. The most common agent or the most common agent by which chemical reactions take place is water, and you know that water is abundantly found in almost every places of earth. Now chemical weathering uh, can affect by five things, or chemical weathering can be done by five things. Firstly, that is the water. Secondly, that is the concentration of oxygen. Third is the concentration of uh, carbon dioxide. Uh, Fourth is the concentration of hydrogen plus ion in a solution, and fifth is the some chelating agent. So I'll come one by one about these processes. Uh, Now, one thing you must know that chemical weathering occurs more rapidly in warm, humid climates. That means where there is temperature condition is high and there is ample amount of moisture in the atmosphere. In those conditions, that is the tropical to subtropical humid conditions, they are chemical weathering is more intense. So if you take a overall look over the Earth's different latitudinal conditions, you will find more chemical weathering near the tropical regions, and as we move towards the higher latitudes, chemical weathering will be less intense. So the different process of chemical weathering, first one is the solution, or you can call also a dissolution of minerals. Second one is oxidation. Third one is hydration. Fourth is hydrolysis. Fifth one is carbonation, and the sixth one is chelation. So these are the six processes by which chemical weathering, that is chemically a pre-existing rock, is broken apart. The first one is dissolution or solution. It is the simplest process where minerals can be decomposed and involves water acting as a solvent. So, how much mineral is getting uh, dissolved or disseminated within the solvent, uh, that is known as its solubility. So solubility of a mineral represents the extent, that amount to which it will dissolve in water. Now solubility is affected by the temperature and also the pH, that is the acidic value, the acidimetry of the environment, or rather of the solvent. What happened during this process? Basically, the chemical compound, which is basically a combination of some cations and anions, they becomes separated. The cations and anions are become separated in presence of some solvent. The most famous example is our natural salt, that is sodium chloride. In presence of H2O, in presence of water, this cation sodium and anion chlorine, they become separated and form sodium hydroxide and hydrochloric acid. So the property of sodium chloride becomes completely lost or changed and forms a new mineral composition. Similarly, silica, SiO2, in presence of water, they formed silicic acid. This reaction is not common. It is occurred in very high temperature. Uh, Generally, in natural conditions, silica is not dissolved easily, but dissolution of silica can also happen. That is why here I show you this example. Next is the oxidation process. Uh, in oxidation, it is the process where an atom or ion loses an electron and thereby getting more positively charged, or in other way you can say that it decreases its negative charge. Now oxygen found in nature, that is occurred in natural water or in the atmosphere, this oxygen is very highly reacting reagent. The oxygen present in atmosphere in different uh, bodies, that is in water and in atmosphere, they readily react with the minerals and oxidize them to form a new mineral setup, a new mineral. One examples of examples of minerals which can be readily oxidized, those are the iron minerals, titanium, manganese, and sulfur minerals. If you take the example of iron, that is the iron present in pyrite, that is in plus 2 valency state. Oxygen reacts it this pyrite and it will convert uh, the ferrous state of iron into ferric state, that is plus 3. So here you can clearly see that it will be more positively charged, or other way the negative charge becomes less due to this involve of oxygen into this chemical reaction. Okay, so the tendency uh, of these minerals to react with oxygen is known as redox potential, or EH. Uh, Similarly, the opposite of oxidation is also known as reduction, where a mineral or chemical element, or you can say an ion, becomes more negatively charged. In oxidation, it becomes more positively charged, whereas in reduction, the opposite thing is true. That is, in if this reaction may occur in reverse reaction. So here you can see that the plus 3 charge is being um, transferred to plus 2 charge. So that means the decrease of positive charge or increase in negative charge. So this is reduction and this is oxidation process, and this will happen due to presence of oxygen. And this tendency of being uh, oxidized or being reduced is known as the redox potential, or EH. We symbol them as capital E, small h. More and more positive values of EH, that indicates more and more oxidizing condition. That means the mineral or the ion is more prone to getting oxidized, whereas negative values of EH indicates that it will be more reducing. Next is the hydration process of chemical weathering. Uh, in nature, some minerals have a marked ability to absorb water in their crystal structure, in their outer periphery, without much altering their uh, chemical structure. Basically, it occurs when minerals absorb water molecules on their edges and surfaces. The water in the crystal lattice when they uh, involved in this chemical structure, they basically increase the volume of the existing mineral. One famous example is anhydride, that is calcium sulfate. When water is added to this calcium sulfate, then without being much change to this chemical formula, the water molecule is simply added to its periphery or to its edges, and thereby increase its volumes and produces gypsum. Similarly, hematite, when uh, water is added to its periphery, it will convert it to ferric hydroxide, that is the rust commonly observed when iron is exposed to atmosphere for a prolonged time. The water vapor uh, in the atmosphere, they will react in presence of oxygen with the iron and changed them to iron uh, hydroxide. That is the process of hydration. So here water is added on the periphery and thereby increase the volume. Next is the hydrolysis, where water react directly with minerals. This in this process, uh, what basically do, the H plus ion of water, uh, they basically uh, combined with another water by replacing the cations of any pre-existing mineral. Uh, some famous example of hydrolysis is the reaction of albite, that is the reaction of potash feldspar, or you can say you can take the example of albite also. So here the positively charged potassium ion, or in case of albite the positively charged sodium ion, they will be replaced by the H plus ion of water and formed aluminosilicic acid. So orthoclase or albite is converted to aluminosilicic acid, and some hydroxide. Here, when potash feldspar is there, it is formed potassium hydroxide. When sodium, and that is albite, is there, they are formed sodium hydroxide. So along with this aluminosilicic acid, some hydroxides of potassium or sodium are formed. Now, uh, this potassium or sodium hydroxide is carbonated to potassium carbonate and water. So the reaction is KOH plus H2CO3, that is carbonic acid. They will convert it to potassium carbonate, K2CO3 and H2. Now this potassium carbonate is highly soluble and removed from the place by the running water. So the remaining aluminosilicic acid, that uh, reacts again with water, this aluminosilicic acid that again reacts with water, and that will form kaolinite, that is a clay mineral. So often you heard in your sedimentology classes that potash feldspar, whenever they suffered sedimentary conditions, and they basically alter to clay minerals and uh, produce uh, clays. So in microscope you will found that potash feldspar looks very dusty, very hazy, because we say that this potash feldspar suffers some amount of weathering and converted to some amount of clay. So that is the main reaction. Potash feldspar in presence of water reacts with the H plus ion of water, forms aluminosilicic acid. This acid again reacts with water and formed kaolinite, that is a clay mineral. And along with this uh, kaolinite, it will also uh, formed uh, a resid sorry It will also form H4SiO4, that is the silicic uh, acid, and this silicic acid is soluble in water, so thereby removed away from the place. Okay. Similarly, olivine also reacts with hydrogen plus ion, and at the same way, the magnesium ion, the magnesium cation, is replaced by this H plus ion. Okay, so that is the process of hydrolysis. Next is the carbonation. Now, carbonation is basically the formation of carbonates, which are the salts of carbonic acids. Carbon dioxide, which is amply found in nature, which is abundantly found in atmosphere, they dissolved with natural waters to form carbonic acid. CO2 plus H2O is equal to H2CO3. Uh, this reaction is a reversible reaction. This reaction uh, then dissociates into a hydrogen ion from the H2CO3. Uh, this H2CO3 dissociates into an hydrogen ion, that is H plus, and a bicarbonate ion, that is HCO3 minus. So from H2CO3, uh, H plus will produced and a bicarbonate ion HCO3 is produced. Now, carbonic acid attacks mineral forming carbonates. Okay, this uh, the bicarbonate ion, which is formed from the carbonic acid, uh, they will react with the uh, carbonates of the rock, particularly the calcium carbonates, and they will formed they will uh, formed another chemical compound, that is calcium bicarbonate. So here in this reaction, calcium carbonate H2O plus CO2, that means this is H2CO3 carbonic acid. This carbonic acid formed H plus ion and bicarbonate ion. That bicarbonate ion reacts with the calcium cation of calcium carbonate and formed calcium bicarbonate. Now this calcium bicarbonate is readily soluble in water and thereby removed away from the place. So due to this removal away of the place, the area becomes void. That means it is eroded. So thereby we'll found some erosional mass, a scratching mass over the uh, calcium carbonate, particularly the limestone, the carbonate rocks. Okay. Now this type of uh, carbonation reaction is very highly found in uh, tropical to subtropical areas. That is why the carbonate rocks and the carbonate structures, uh, they are highly affected by this process of weathering. You may heard about the wearing away of Taj Mahal, which is made up of marble, that is a calcium carbonate. Now, when there is a high amount of carbon dioxide due to atmospheric pollution, we know that our carbon dioxide uh, concentration is gradually increasing in the atmosphere, and when there is ample amount of rainfall, this atmospheric carbon dioxide reacts with the raindrops, reacts with the water molecule of atmosphere and forms carbonic acid. Now when these carbonic acids fall over the surface of Taj Mahal, that is the calcium carbonate, it reacts and forms calcium bicarbonate. And as I already told you that this calcium bicarbonate is readily soluble, so removed away from the place, and thereby weathering happens. So day by day Taj Mahal suffers weathering. That is the main type of chemical reaction uh, for which Taj Mahal is affected. The next type of chemical weathering is known as chelation. This is the removal of uh, metal ions, particularly the aluminium, iron, manganese. These ions are removed away from the solids by reacting with some organic acids. Now, the organic acids, these are basically formed by some biotic bodies, particularly the plants. The plants formed some kinds of organic acids into their rootlets, such as the fulvic acid, humic acid. Now, whenever these organic acids they came into contact with these uh, ions, with these chemical elements, they will form a uh, complex organic uh, compound that is composed of some organic matter as well as some metallic matter. This type of weathering is known as chelation. So chelation encourages chemical weathering and transfers metals in the soil. So the organic produced in the soil, they will react with the surrounding rock mass and removed this type of metallic ions to the to the soil, which are the raw nutrients used by plants during their photosynthesis. So this process is known as chelation, where weathering happens due to the presence of some organic acids which is made by some biotic bodies. Here you can see some pictures of acid rain, that is the effect of carbonation, some pock marks, some erosion, chemical erosion on some statues, rocks, and the results of oxidation, due to which the iron is converted from Fe+2 to Fe+3, and the rocks become more reddish in color. That is uh, a very good natural site to study the chemical weathering processes. The next type is biological weathering. As the name suggests, bio means life. That means the living beings, they are responsible for these kinds of weathering. Now, uh, in biological weathering, one famous example of biological weathering is root penetration within the pre-existing rocks. Growing of rootlets of different shrubs and trees exerts an incredible force when they are uh, growing along the fractures, pre-existing fractures of the rock mass. Now, one funny thing is that, which we almost don't know, that the cellulose of the plant body, uh, of which all the cell walls of uh, plants made, they are actually more stronger than many metals. So we thought that due to penetration of root through the uh, through the cracks of the pre-existing rocks, the plant body maybe suffered some injuries, but that is actually not due to the presence of cellulose, which is much harder than our imagination. So due to this growing of rootlets through the fractures, they will create some pressure to the fracture walls, and ultimately those fractures or those cracks are widened by expansion. And the with successive growth of the plants, uh, these cracks are ultimately results for separating of the rock mass from its original um, rock body. Similarly, some animals, particularly the earthworms or the burrowing animals like rat or other kinds of rodents or other kinds of termites, they play an important role in preparing material for removal of rock mass. They basically dig into the underground surface and thereby loosen the rock material or loosen the earth material. And sometimes these organisms, the earthworms, rodents, termites, in search of food, they directly take the entire loosened rock mass or entire rock mass in search of food, in search of nutrient. And the digestive system is such that from that nutrient rich rock mass or nutrient rich sediment, they selectively take the nutrients and remove the rest of the rock mass, rest of the sediments uh, as excreta. So they take all the nutrient rich sediments, the digestive system only taking the nutrients, and the rest of the rock mass, they are removed as excreta. So in this process, the pre-existing rock mass, they basically loosen. And sometimes the animals make their nests or make their shelters within the rock mass by digging the rock mass, and thereby also loosen the rock mass. Now coming to the factors which controlling weathering, the first and foremost factor is the climate. As I already told you, some areas suffer more intense rainfall, whereas some areas suffer intense temperature difference. And you all know already, in nature there is uh, temperature variation across the latitude, so thereby all the geomorphological processes, uh, they will vary from place to place. They will vary across latitude and they will vary from place to place, and thereby the climate condition of those areas are also different. So that will affect uh, to occur different geomorphological processes in different intensity. Second is the nature of parent rock, how much weathering or how much fragmentation is occur of the parent rock. That will depend on the composition, that means the structure and mineralogical composition of the parent rock. So more and more pre-existing weak plains, more and more soft rocks, more and more fine-grained rocks found, that will be more prone to weathering. Second is the nature of weathering agent. That means which kind of weathering agent. That's whether it is the areas is suffered by mainly aeolian or fluvial water dominated or glacial, that is ice dominated environment. So depending upon the weathering agent, the weathering processes may differ and thereby the products also vary. Next is the topography and drainage area. That means where the area is a flat land or an uneven topography or a hilly terrain. Similarly, depending on those areas, the geomorphological processes varies and thereby the effects will be different on those areas. The vegetation cover, vegetation basically uh, protects the soil cover to being removed away, but at the same time intense vegetation in an area uh, results more biological weathering and that area suffers more rainfall also. So in a sense, vegetation protects the soil to remove away, but weathering um, is also done by the vegetations, by the plants. The last and foremost is the duration of action, that is how long the natural agents will act over an exposed rock surface. And that will also govern how much weathering, how intense weathering uh, the area will face. Now here you can see a simple picture depicting the relationship between mean annual precipitation, that means the annual rainfall, and annual temperature variation. You can see in case of mechanical weathering, as you increase the temperature and similarly as you increase the rainfall, mechanical weathering will be more weak. Similarly, chemical weathering will more intense, will more strong as you increase the temperature and rainfall. So in higher temperature and higher rainfall, chemical weathering will be more prone. Whether in lower temperature and low amount of rainfall, mechanical weathering is more strong. Now if we combine these two pictures, that is both chemical and mechanical weathering, with respect to temperature and rainfall, you can see there are different sectors. In the higher part, more chemical weathering; in the higher temperature, higher precipitation part, more chemical weathering will occur, whereas in the lower temperature, lower annual rainfall, strong mechanical weathering. And in the intermediate portion, where the moderate temperature and moderate rainfall is there both chemical weathering will both chemical and physical weathering will affect, but as in this case rainfall is very much high in contrast with the temperature, so chemical weathering will be slightly more prominent. So in a sense, physical weathering or mechanical weathering will be almost restricted to the uh, cooler regions, that is the regions where um, during the daytime temperature at least goes below 0 degree, at least once goes below 0 degree, whereas all other places where there is ample amount of or sufficient amount of rainfalls occur, in those areas mostly the chemical weathering is more dominant. In contrast to this, there is some area where the area suffers much hot, that means much heat, temperature is high, at the same time the rainfall is very poor, so those areas are very less affected by the weathering processes. Both physical and chemical weathering are very low in these areas. That is the relationship between uh, annual rainfall and annual temperature. Now, if I draw a section of the weathering rock mass, we get these kinds of picture, that is known as the weathering profile of any particular uh, rock mass. Now here you can see that at the extreme bottom there is the fresh rocks which have to be eroded. This is the fresh bedrock. After weathering affects, the fast formed material is the slightly loosened up materials, which is known as sap rock. The boundary between these fastly formed uh, loosened materials, and that is the boundary between the bedrock and this sap rock, is known as the weathering front, whether all these loosened or weathered fragments of pre-existing rock, they are known as regolith. The layer immediately above the weathering front is called the sap rocks, that is this portion. This represents the first stages of weathering. Above the sap rock, that is known as saprolite. So as we move more towards the superficial condition, weathering effect will be more intense. So in contrast to sap rock, saprolite is more weathered. That means the parent rock characters uh, is more lost in saprolite with respect to sap rock. Okay. And above the saprolite, uh, there is no particular name for those zones, but it is known as mobile zone or zone of lost fabric or often pedolith. If we consider the fresh rock characters, if in this fresh rock characters is defined that here in this portion it is present as 100%, so it is present as 100% the bedrock character. In sap rock, that is the layer immediately above this fresh bedrock, here the pre-existing rock character is present about 90%. In saprolite, the character present is 50 to 90%. So gradually the parent rock character is decreasing up through the rock body, that is decreasing towards the surface. And in the mobile zone, in this condition, it is less than 50%, and towards the surface where mostly the soil formed, here the parent rock character is almost zero. So from 100%, it gradually decreases up to the surface and becomes zero to the surface. Uh, Duty crusts are normally significantly harder, more resistant to erosion. Sometimes a duty crust seem to be preferentially developed at low points in the landscape where ground area flows and surface runoff converge. This armoring can subsequently lead to the more rapid lowering of surrounding areas and the creation of uh, inverted topography. Here you can see that over these areas, some kinds of fluid flow occur, and during this fluid flow, some kinds of dew crust coating will also happen over this surface. Now, with subsequent time, the adjacent areas, these areas, these will suffer more intense weathering. And because of the presence of debris crust or hard pans over these areas will not suffer uh, much weathering like in contrast to these areas. So this will remains as little elevated part in contrast to this portion. So same area, due to the presence or very close areas, due to the presence of debris crust, they become more weathering resistant. In contrast, the surrounding landmass becomes much lower due to becomes more intense weathering because they did not have any protection cover. This type of topography is known as inverted topography. Weathering and climate change. Uh, Weathering act as a negative feedback that moderates long-term climatic change. So warmer climate results increased temperature, precipitation, and vegetation, which ultimately gives increased chemical weathering. That means increased carbon dioxide removal weathering. That means more and carbon dioxide is being dumped to the atmosphere, which ultimately results global warming. Similarly, uh, colder climate, that is decreased temperature, decreased precipitation, that means chemical weathering is less intense there. That means carbon dioxide is less removed from the rock body. So in atmosphere, carbon dioxide is less put up, and ultimately this results in initial cooling. Uplift of an area, that is steep slope, mass wasting, seismic activity, increased rainfalls, mountain glaciation, increased rock fragmentation, mainly physical weathering, increased weathering and carbon dioxide removal of the atmosphere, and thereby global cooling. So these are the effects of weathering by which the climatic condition of an area in long term that will also changed. So not only weathering, whenever we study geomorphology, not only weathering gives some particular type of landform, some particular type of landscapes, but also in long term weathering affects the climatic condition, uh, at least regionally and in some cases globally also. So that's a brief introduction or brief knowledge about weathering uh, processes, different weathering processes, and as I already told, erosion is simply removal away of this weathered mass from its host body by the natural agents. So thank you. Hope you will understand. See.